The project today is all about the multi-storey car park 6. The car park's been built for about 4 years now, and 2 years ago it started suffering from structural defects. The ground floor is still in use, but the suspended floors, that's all 6 of them, have been closed to cars, unfortunately. The two root causes are the corbels, which are suffering a bit of cracking, and also the connectors that tie the whole of the precast slabs together, as some of them have failed. So we need to cut out those connectors and stitch the precast units together using in-situ concrete. The problem is how you cut the concrete out without ruining the reinforcement, which is very important to stitch it together. One of the methods we're using, and we've trialled over the last few days, is a method called hydroblast. It is a high pressure water system which actually cuts into the concrete but doesn't damage the reinforcement.
So you can't use a normal breaker on the decks. It would cause damage that we wouldn't see. So we use a jet of water that is travelling at 1,000 miles an hour.
The operatives position the robot close to where the jetting needs to take place. They secure the high pressure hoses, and the operatives set the limits on the machine according to the size of the hull. The working zone needs to be cleared of any unnecessary operatives, particularly the air underneath where we're cutting, as that's the most dangerous. The robot uses around 260 litres of water a minute, and this water needs to be managed. It's collected and pumped into a water treatment system which takes the pH levels from around 12 to 14 back down to between pH 7 and pH 8. It does this via a CO2 treatment machine. The water is then put through a silt buster to remove suspended solids, and this means it can then be discharged safely into the stormwater system.
Hydroblasting is potentially quite a dangerous operation. As part of that, we have whip restraints on the high pressure hoses. We had to put a lot of acoustic damping in because the decibel levels were peaking at about 100 decibels, which is well beyond our terminal limit of 85. So going forward, we're going to put a program together based on the timings that it's taken to carry out the trial, and based on those, we'll be able to work out a cost and get the car park back into operation.
It's quite quick. We need to take precautions in terms of the environment, the noise, and this is what these trials were all about.